Tonight's video is on electronegativity and its relationship with bonding. Let's recall from grade 10 the octet rule, which states that when atoms form bonds, they're going to gain, lose, or share in order to get 8 valence electrons. Which of those three things that are done depends on what the electronegativity value is of each atom individually and the pair collectively. We work out the difference by subtraction of the two values to get the bonding type. We always subtract the smaller number from the larger one in order to get a positive answer. The difference in electronegativity should never be negative. For example, with sodium chloride, if I look up the value for chlorine, I find it's 3.0. If I look up the value for sodium, it is 0.9 on some periodic tables, others it has a 1. And so when I subtract, I get 2.1, and it's a positive value. If I take the case of ammonia, I look up the two values on a periodic table. Nitrogen is 3.0, hydrogen is 2.1, so I'm going to put the larger one first. That means I have 3.0. I'm going to subtract the hydrogen, which was 2.1, and I get 0.9. We're going to move on in 3, 2, 1. Bonding types. In the grade 11 course, we're focusing in on just two bonding types, ionic and covalent. Ionic bonding leads to ionic compounds. Covalent bonding leads to molecular compounds, which are going to have some very different properties that we're going to discuss as we go through this unit. If the difference in electronegativity is 1.7 or larger, if we know we're dealing with a metal and a nonmetal, or if you have a metal with hydrogen, these will all be examples of ionic bonding. In contrast, for that covalent bonding, you're expecting the difference in electronegativity to be less than 1.7, or you're dealing with two nonmetals. There will be some exceptions to this, but that is a general guideline. Moving on in 3, 2, 1. We're going to spend some time with names and symbols of covalent compounds. I'm going to start with some elements. Elements are given their symbol followed by the subscript for their state. The states you probably remember from grade 10. They're fairly self-explanatory. S for solid, L for liquid, and G for gas, all of these being normally written as subscripts. I didn't make them subscripts here just so they're larger and easier to read. For example, if you're given the name fluorine gas, that means its symbol is going to be F. It gets a subscript 2 because this element is diatomic, and because it's gas, it goes like that. If we've got the symbol I2, bracket S, that means that is iodine solid, which is what iodine is in its standard state. Next, what I'm going to talk about are common substances. Common substances are materials which have been around for a long time. We know what they are, but they were given names before we understood what their chemical composition was, and as a result, the common name has stood in spite of what the new naming system would normally assign it. Best example, water, which we probably all know as H2O. Ammonia, NH3. Methane, CH4. Ozone, O3. Hydrogen peroxide, very similar to water. It's H2, but the per in front of the oxide means there's an extra oxygen, so it's O2. Hydrogen sulfide is actually H2S, Originally, people didn't realize there were two hydrogens associated with the one sulfur, so they just called it hydrogen sulfide. And the last one is silicon carbide. Silicon carbide has the symbol SiC. This is the material that we think of when we talk about carbide tips for drill bits and blades to make them last longer. Those are our common substances and the elements. We're going to move on to the naming system for the other substances in 3, 2, 1. All right, so all of our other covalent compounds, when we start with name the symbol, there's going to be some prefixes that state the number of each atom. If you don't see a prefix, that means 1. And these prefixes are going to tell us which number to write, but the number we write is a subscript after the element, which is going to seem a little weird because a prefix goes on the front of the word and the number showing how many atoms there are comes after the symbol. So we're going to have to keep that straight. And if the prefix is for 1, we don't write 1s. If there's no prefix, we still don't write 1s. We're going to have a chart here that shows us all of the prefixes from 1 to 10. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So you might want to pause the movie for a moment, get those all down. And we're going to look at a few examples now. So here's a good name, carbon tetrachloride. The word carbon has no prefix, so it's just the letter C for carbon. The next word is tetrachloride. The chloride means that I'm dealing with the element chlorine. And the prefix tetra stands for 4. So remember, the number of the atoms goes after that particular element. So tetrachloride means Cl4. Oxygen difluoride. There's no prefix on oxygen, so it's just capital O. Difluoride means 2-fluorine. So I write the symbol for F for fluorine and then a 2. Last example for this case, dinitrogen pentoxide. There's a prefix on nitrogen. Whenever the first element has more than one atom, you have to record the prefix saying how many there are. So dinitrogen means N2. Pentoxide, that's oxygen with a prefix pent meaning 5. So notice if the first element is only 1, no prefix. If the first element is more than 1, there is a prefix. We're going to move on to the last slide now in 3, 2, 1. Going from symbols to names, you're going to write the name of the first element, and if there was a prefix, you're going to give it one, representing how many atoms there are. Second element gets a prefix all the time, and you change the ending to IDE. P, F, 3. So the first element, there's only one of them, so I simply record that it is phosphorus. Now I have to look at the subscript. Subscript is a 3, so that means tri. And the element is fluorine, so FlUOR. There's no flour in fluorine. And then the ending changes from INE to IDE. So phosphorus trifluoride. Next example, IBr5. Again, the first element, there's no subscript after it, so that means there's one of them. There's only one, there's no prefix, so that means it's iodine. There are 5 bromine, 5 is penta. Brome, and remember the INE changes to IDE, so iodine pentabromide. Last example, N2O. Now I've got a subscript for the first element, so I have to use a prefix for it, dinitrogen. The second element always gets a prefix, so monoxide. Dinitrogen monoxide. And that's the last slide, and last example, so thanks for watching.